Hi folks, and good afternoon to this afternoon's webinar, which is all around VMware's vSAN, specifically version 6.7. And we're going to take a slight technical deep dive into vSAN, what it can do, what its features are, and so forth. If you have any questions, please feel free to use the question section of the dashboard at the right-hand side. I'll try and answer them as we go along, or we'll have time, hopefully, towards the end for a Q&A session. We're trying to keep the webinar between 30-35 minutes long today. So without further ado, let's get going. So my name is Mal Toner. I'm a solutions architect here at Novascope, been with the company just over 5 years. Previous to that, I worked for a number of managed service organizations throughout the United Kingdom, and I've been dealing with VMware since it was first introduced into the UK back in the late 90s. I thought I'd start off today by just doing a quick recap about what vSAN actually is. Most people nowadays have heard of vSAN and probably are familiar with its basic premise, but what actually is it? So vSAN is a hyper-converged infrastructure solution that is powering the VMware solution. So VMware vSAN is part of their HCI solution, which is made up of the ESXi hypervisor as a start, vSphere as a management tool, vCenter as a management console, and vSAN as a method of providing storage. So for those of you who aren't familiar, hyperconverged is a solution whereby the same x86 platform is used not only to virtualize CPU, memory, and networking for a VM, but is also used to virtualize storage for the VM. The idea here that we can have enterprise grade scale and performance with lower costs. The whole idea of the vSAN solution is that we can actually use storage associated with the ESXi hypervisor host as the storage for the VM, but actually retain all the features that we're used to having in a SAN, such as resiliency, availability, scalability. Now, not all HCI solutions, hyperconverged infrastructure solutions, are the same. There are a number out there in the marketplace that actually run alongside ESX, but do so by redirecting all of the VM storage requirements through another VM sitting on the host. So the diagram shows you that each host has a storage VM that controls the storage underneath, and then the little VMs in the blue on the diagram actually connect through that storage VM to get. This actually means more hops, context switches, and queues. It forces up the host CPU utilization in order to fulfill the I/O, and therefore leads in a lower consolidation ratio, i.e. number of VMs per host. vSAN is different in that it is fully integrated, being written by VMware themselves, into the vSphere kernel. So it is actually a component of the vSphere ESXi kernel, an add-on component, albeit, that actually controls the underlying disks. Now, it's worth noting at this stage that the underlying disks are fully controlled by the hypervisor and the vSAN components. So all RAID functionality is done at software. This is software-defined storage at its most simple. All RAID is defined by the software. All disks are controlled by the software. In fact, if you get into it, if you're looking at normal disk controllers with inside the hosts, things like write caching is recommended to be disabled in a vSAN environment so that vSAN can deal with everything. Again, to talk about vSAN in a little bit more detail, vSAN has two feature sets, or two types of solution. vSAN all flash, where you basically are using either all SSD, PCIe, or NVMe storage to provide your capacity, or vSAN hybrid, where you're using SSD, PCIe, or NVRAM for a caching layer, and then using capacity made up of either SAS, nearline SAS, or SATA drives underneath. The reason I point this out is that some of the feature sets that are available in vSAN are actually only available on the all-flash array. So for example, vSAN now includes in the latest edition, well, the latest two editions, something called RAID 5 and RAID 6 erasure coding, which I'll come back to a little bit later on, and that's only available when using an all-flash system. Indeed, the dedupe and compression facilities again are only available in all-flash. Performance is better in all flash, as you can imagine. All of the storage operates at all of the same performance levels, whereas in the hybrid environment, we have this idea of a read and write cache sitting in the SSD, PCIe, or NVMe RAM, whereas that is then destaged to old spinning disks at the bottom. When we talk about space consumption, because the hybrid vSAN only supports historic RAID 1 functionality, for every 100 gigabytes of disk that VMs will consume, you're actually going to require 200 gigabytes of spinning disk underneath. Whereas when we're using vSAN with RAID 5 or RAID 6 erasure coding, then for 100 disks, for example, when we're using RAID 5, we only need 133 disks of space. By the way, all of these slides will be available at the end of the presentation. If anybody wants a copy, just send a note through to the meeting organizer and we'll get a copy sent out to you. So what's different about vSAN? So one of the unique things about vSAN is that when you actually create vSAN, whether you've got a hybrid or an all-flash system, depends whether you get certain features like RAID 1 versus RAID 5 and 6 erasure coding. But then you actually have the ability to get what we call the storage policies on a per VM basis, or even on a per VMDK basis. Yeah, so I can actually take some of my software resilient architecture, such as Active Directory domain controllers, DNS servers, DHCP servers, and maybe not even assign a failure to tolerate policy against those. But I might take some more mission critical systems like an SQL database and set that as a failure to tolerate 1 or 2 even. Or I might even say, well, actually, that's fine because I've got a SQL always on availability group across the cluster, but my application layer that sits in front of that has got no availability, so that needs to be set at a different fault tolerance level. So we have full control of the fault tolerance level based on the individual VMs, compared to an old SAN environment where the fault tolerance level would be based on a data store or a LUN basis. Setting a storage policy is pretty simple. You basically set the storage type, the primary level of failures to tolerate, which we'll come on to second, the failure tolerance method, whether we're using RAID 1 or RAID 5, 6 erasure coding. And again, remember RAID 5, 6 is only available in an all flash solution, and whether or not you reserve the space for the machine. So how does this work? So basically, let's talk about failure to tolerate 1, which is RAID 1 mirroring. Basically, this means that for every block of data I write, a duplicate block of data is created somewhere else inside my vSAN environment, and a witness is created somewhere else. So straight away, you can see that when we talk about vSAN, we talk about vSAN nodes. The number of nodes that make up a vSAN dictate your failure to tolerate capability. So a bare minimum for failure to tolerate 1 is to have 3 nodes. When a node in the environment fails and it contains a block of that data, a couple of things happen. First of all, we recognize that that's happened straight away. The next thing is we will wait, or by default, wait 60 minutes before attempting to rebuild the missing data. So in a failure to tolerate 1 environment, that would simply be use the existing live blocks to remirror to another host inside the environment. So as I mentioned a few minutes ago, to set up failure to tolerate 1, you must have 3 nodes, block of data, mirrored block of data, and witness. But to actually do anything realistic, failure to tolerate needs 4 nodes, because we need a 4th node to be able to rebuild. If after 60 minutes the original node hasn't come back up, the rebuild process starts. Reason for waiting 60 minutes is that might just be a maintenance window. You might be doing a reboot of a host to incorporate a patch process or something like that. In the event that it isn't actually the host that goes down, but the drive that's holding the data within inside the host reports an error, then vSAN starts the rebuild automatically. So we talked about failure to tolerate levels. So here's an example. We've got a 6-host environment. We've built a VM. We're setting it to RAID 1, which is the failure to tolerate 1. So we get data and we get a witness disk. VM 2, we set that to failure to tolerate 1, but we set it to RAID 5, 6. So I'm going to pause the diagram there to explain a slight difference here. When we set it to RAID 5, what actually happens is the data is split into 3 equal chunks across 3 of the hosts in the node, and then erasure coding is used to generate enough parity information. In the event that any of those chunks are lost, we will get the ability to recreate it. So with RAID 5, every time, no matter how many hosts you've got, data is split into 3 chunks with a 4th parity. If you choose RAID 6, what actually happens is the data is split into 4 chunks and 2 parities, and that gives us the ability to failure to tolerate 2 components. So, quick recap on what vSAN is, what its capabilities are, what's new in the latest edition of vSAN. So where we are now is we're on vSAN 6.7. And that has brought out some more intuitive operations experience, some more consistent application experience, and a more holistic support experience for the end users. Any information you want on vSAN can be found on VMware Storage Hub environment. There's a lot of YouTube videos out there as well, and they're definitely worth researching. So if we talk about intuitive operations experience, in keeping with everything else, we've moved to a HTML5 or Clarity UI framework. This gives us a new way of presenting and looking at the vSAN configuration. It allows workflows to be developed from the ground up. It allows the new vSAN functionality to be available through the HTML5 client, and the legacy Flex client is still available. And that's important because some of the other third parties that sometimes hook into vSAN for operations, maybe like backup and snapshot, sometimes rely on the legacy Flex client. Here's a little bit of cross-sell. We have augmented vCenter intelligence with analytics from the vRealize. So I'm not sure if many of you are familiar with VROps or vRealize Operations Center for monitoring event history, alerting, and insight and trending. We've tightly integrated vSAN more within there. So you can see now we've got pre-built VSAN dashboards with inside vRealize Operations Center. It's fully integrated into the vRealize Operations Center 6.6, which in itself is using the same Clarity UI. It's easy to customize, and it can display both vSAN and non-vSAN metrics together. And this is important because you might have an old or an additional array that you want to use alongside your vSAN. You don't have to have everything on vSAN. You might only have vSAN for an initial dabble for test and dev environments. You might have vSAN for some other legacy environments. You might have an array for legacy environments, but this brings everything together into one view. It also allows us to see multiple vSAN clusters if that's the way you're built up. And the important note here is that vSAN can have multiple clusters, so you can manage multiple environments together. It might be split across multiple data centers, or if you're a business like ours, where we're actually doing hosting for clients, split across one data center but multiple clients. Another thing that vSAN can do, which I didn't mention earlier on, is you can actually set what we call fault tolerance domains. So you can actually make rules inside your storage policies that keeps your vSAN out or across multiple fault-tolerant domains. So you might have, I don't know, 12 hosts per rack and a total of 36 hosts across 3 racks, and choose to do your storage policy across the racks using each rack as a fault-tolerant domain. We've got a VROPS plugin for the vCenter HTML5 client, which gives us new dashboards, as I mentioned earlier on, and consolidates everything into one view. And this really goes back to the whole idea of, why are we seeing businesses moving towards hyper-converged infrastructures? Because everything's visible in one area. We're removing the silos of different tasks or different specialisms within inside the data center and making everything available. Another interesting one is, for the first time in this release, we actually have full support for vSAN presenting its storage either internally to a VM using an ISCSI initiator, or indeed externally to a physical host, for example, a Windows cluster failover host using an ISCSI initiator. So up until this release, vSAN storage could only be consumed by virtual machines on the hosts within inside the vSAN cluster. With this release, I can actually say, well, hold on, that hardware manufacturer is insisting that I run on a Windows physical server with a physical clustering, maybe some sort of SQL clustering or whatever, and therefore I want to be able to present the same storage that I've invested in inside my vSAN architecture out to some physical hosts. Consistent application performance. One of the things that we've seen a change in over the last few years is that because we now have the speed and capacity entering the SSD, the non-spinning market, at a price point that is palatable to the industry, we're seeing more and more people moving towards an all SSD environment and basically saying, I no longer have to worry about IOPS. Back when I entered the SAN marketplace, the first thing you had to do was design your RAID level to get the right number of spindles in there to give you the right IOP performance to run the application. With all flash deployments these days, and indeed to a certain degree with flash hybrid deployments where we're doing read and write caching at the flash layer, those IOP requirements have gone out the window. So we're now getting consistent application experience. But what we've got to make sure is that the application experience is consistent across the full suite of applications. So what we've seen recently is the improved IO performance with Adaptive Resync. So basically, when we see a contended resync IO or a contended IO path, resync will be guaranteed at least 20% of the bandwidth, which basically means that the VMs will still get the lion's share of the bandwidth on the IO path, 80%. If there's no resync happening, we don't just hold 20% back, we still give the VMs all 100%. But it actually means that when we get congestion signals, we're not being detrimental towards the application consistency in order to resync the data. But in the same respect, we're not affecting the resync of data by the applications. We also get the ability to do faster decommissioning. So you may have remembered earlier on I talked about when you need to take a host out for a patch. If that host had a VM's data on it, vSAN's going to realize a block of my data is gone. I'm in a degraded failures to tolerate state. So I've got to rebuild the data, but I'm going to hold off 60 minutes just in case the block comes back. Well, what if you know the block's never going to come back? What if you're actually taking the host out on purpose? So this is the idea of being able to decommission. So we consolidate the replicas living across multiple fault domains. We open up the fault domain as a target for the objects during the decommissioning. We look to move the smallest component. So if we can actually move the smallest component, maybe a witness disk, rather than do anything else, we'll do that. Yeah, and this results in less data being rebuilt, less use of temporary storage space, less contention on the IO path. We also, up until this release, we had an issue whereby the vSwap objects actually didn't follow the same storage policy as the machine themselves. By default, the vSwap objects were always thick provisioned, and by default, they didn't inherit the same storage policy. So that is now fixed, yeah? They can now automatically be thin provisioned, depending on what your thought process is there. I work with a lot of people who say thin provisioning is a short way to get yourself in trouble, and they prefer to thick provision all the time. But they can be thin provisioned. They'll inherit the policy applied to the VM rather than to the VSAN default storage policy, which means they get the same failure to tolerate of the swap object. If you are in a position to use disparate, separate switching backends for the vSAN IO communications channel, we can then put improved resilience for failures inside there by using each different VM NIC on a different subnet. If we see a failure anywhere in that subnet, we fail over to the second fabric. Again, we've done some work in the previous release of vSAN, the 6.6 release, we actually had support for stretch clustering. Do be careful, don't get overexcited about this. Stretch clustering does allow us to stretch the clustering across 2 data centers, but you do have to meet some very tight round trip times for latency in order to be able to do this. But where we're doing this and we're using a third site as the witness host, we now have the ability to have a fully separated witness traffic from the vSAN data, yeah? Which basically allows us to make sure that we don't get contention or false witness being bared in the event of contented IO. And again, we also have intelligent site continuity through this. Again, now that we've got the third witness host, we track the fitness of each site after a full partition event to set a preferred site. Once a preferred site is set, in our case, site on the left, the secondary site, even if it came back up online, would actually stay in a field failure until we manually set it to come back. We also take advantage of some of the technology that is inside vSAN itself. So the idea that when we're writing data to disk, we only write unique blocks to disk when we're using SSD for dedupe and compression. We also take advantage of that idea to actually make sure that if we're trying to reestablish a sync to a remote site, then we do that in such a way that we're only sending unique data over. So, yeah, so it reestablishes a proxy owner in the target site, does a partial resync, establishes the owner, and then brings the local copy across. Yeah, so that minimizes the traffic going across this intersite link. And the newest thing is a holistic support experience. So this is decreasing the time to resolution. So this is almost like a call home feature. Yeah. So we basically have intelligent support through vSAN support and insight. This will provide anomalized data to the VMware global support team, real-time identification of conditions, that will allow us to do proactive support capabilities out to the larger community. So it might be that through this anonymized data, we realize that someone has done a patch at a hardware level to an ESX host. That might be a vSAN ready node or a vSAN node that's on the hyperconverged manufacturers list, like I think it's the Dell EMC vRealize is the leading one in there, but others do exist from Nutanix and Supermicro and so forth. But what we can see is maybe there's an event happened in a client somewhere in the States that they've done a patch. That patch has caused a problem to vSAN, and as a result, we can actually say to the larger community through an announcement, please don't apply this patch, it's causing issues, and it gets you proactive support capabilities. Health check enhancements, so improve performance of your VSAN health, remove the duplicated health warnings, health checks delivered between product updates, HCL updates only fetch the update differences for your system, and improve debugging for the ASX command line interface commands. We've also got new host maintenance mode, new host maintenance mode verification to ensure proper decommissioning, new host consistency state, improved vSAN vMotion network connectivity checks, service installation checks, physical disk health checks, and firmware checks now independent from firmware driver. And there's many, many more. So that was a whistle-stop tour of some of the stuff. We've also got Diagnostics Partition for core dumping has been introduced. Interesting one, we've now got support for the 4K N devices. So I don't know if many of you are familiar with, but the older disks in the market sector were still running at 512E, or because of the software they're running 512E emulated block storage. We get a lot more performance when we use VMFS6 and vSAN extended to the 4K block storage. So this actually, if you imagine, takes out 8 I/O operations down to 1 I/O operation by moving from 512K block sizes to 4K block sizes. For those of you who work in secure marketplaces where you need accreditation and verification of data at rest and so forth, we've got FIPS 142 validation now via NIST for the vSAN solution. And this is actually an important note here is we're not relying on data at rest encryption from the drive manufacturer. We're doing the at rest encryption with inside the vSAN environment itself. So as I said, I promised to keep it around about 25-30 minutes. We are at 30 minutes now. Takeaways for today. For those of you who are maybe new to vSAN, there's a lot more knowledge, and please feel free to reach out to your account manager if you want us to spend a one-on-one session with you around vSAN and what it can do for you. There's also some intuitive operations experiences that we talked about with the HTML5, the consistency of application and vSAN performance, and the new holistics approach experience. So without further ado, let's see if we've got any questions. Ways to move forward. I can see there's no questions at the minute, but if you do want to move forward, we can work with you to do a vSAN assessment. We can actually get you access to a hands-on lab with inside vSAN, or indeed show you our single-tenanted cloud solutions that run on vSAN, and feel free to reach out to the VMware Storage Hub resources. On that, thank you very much for your time, and hopefully we'll see you on the next webinar with Novasco. Thank you.